what we now want to look at is the switch construct, right? It's again a conditional statement. It's a conditional statement. The syntax of the switch construct is like this. We have got the keyword switch. Right, then it also is a body, just like the other conditional constructs that we have looked at. Right, so we'll be having a switch variable here. You're supposed to have a switch variable. The switch variable, it can be any integer type, that is byte, long, short, int, or it can be a string, or it can be a character, it can be an enumerated data type. Those are the legal data types that you can actually use for the switch variable, right? It sort of can be used in place of what? In place of the if block. But the comparison operator will only be what? Equals. Doesn't work where you've got a comparison operator like that one, greater than or equal, or less than or equal, or less than or greater than or not equal. It only works where we have got the equality comparison operator, right? So if you have got maybe an if-else block where maybe you are looking at maybe ranges of values, it might not be appropriate to use what the switch construct if you have quite a number of these values. But if you want to match a particular maybe a number or match a particular string, it might be better to use what? To use the switch, because it's much more readable as compared to what? Compared to the if-else clause. For example, let's say maybe you want to write a program to test whether a certain input character is vowel or what? Or consonant, right? You can do that using an if statement. You can also do that using what? Using a switch. Because here you are comparing what? You are comparing one character to what? To a particular variable in your loop control. Sorry, not loop control. In your conditional statement, right? You are not comparing it to a range of values, and you are using the equality operator, right? So let's assume that maybe we want to use the switch construct to just check if a particular character is want to check whether a particular character is a consonant or not. Then maybe we can initialize it to maybe what? To W or whatever. Then here we put the switch variable. And like I said earlier on, the switch variable, it is supposed to be either an integer, a string, a character, or an enumerated data type. So I have declared this variable later. That's what I'm going to use as my switch variable. Then inside the body of the if, I have got cases. I have got cases where I compare the case value with this switch variable. I compare the case value with the switch variable. If there is a match, that particular case is what is executed. So this is how you define your cases. So you have case, and then you specify the what, the case maybe like A, then a colon, then after that you have what, the body of the case, right? So what I can simply do is I can either print system.out.println vowel, sorry, it's supposed to be double quotes, right? So that's the first one, that's the first case. Again, you have the other what, the other cases. Right, then maybe here I put what, I put then that case, then that case, and then the last one, the last case. Right. Then after this, I can have what is called the default case, which is more or less similar to the else clause, right, of our if-else what, if-else construct. We can have a default, then colon, then we have what, maybe character is not vowel. Character is not vowel. Right. There's something that maybe the designers of the language forgot to implement. Right. If you look at the case, if there is a match, because we are saying here we declare variable, which is our switch what, our switch variable later, right? Then we have the body of what, body of the switch what, switch construct, where we are comparing this what, this switch variable to each of these cases. We are comparing, right? And we are assuming that the moment there is a case, it is supposed to want to break or exit that switch what, switch, just like with what, with the if, right? So with the if else what, if else or if else if what construct, if a certain what, a certain condition is true, it means all the other what, all the other conditions after that will not be what, will not be executed, or it will not even attempt to try to what, to check if those conditions are valid, as long as there is one, there is a match, right? But here the problem is that even if there is a match, it will continue to what, to check until it gets to the end of what, end of the switch construct. There is a match, it continues to what, to check whether this switch variable matches what, matches the cases. So how do you deal with that problem? You simply have to add a break statement after each case. Let me maybe just maybe print before I add the breaks. For example, if I initialize what, I initialize letter to W, it is going to start by checking is A equal to what, W, then no. Then it will try is E equal to W, no. It will try the next case is I equal to W, no. O equal to W, no. u equal to w, no, then it will, so it is supposed to what, to execute that default case, right? If there is no there is no match. But the problem is that if you don't add the break, it is going to what, it is going to execute all the cases before this one, or the last default case. They are going to be executed. So we are going to see quite a number of vowel statements being printed. All right, let me run. Oh, sorry. Correct. Right, it appears as if the problem has now been rectified. Right, so if you look at this, we have initialized our what? We have initialized our letter to what? To E. So it will check against each of these, and then it will print vowel. Then it will print vowel until it gets to the end of what? Until it gets to the end of the construct. Yeah, it's sort of a design error. So just need to add what? Just need to add a break after each case. Otherwise, it will continue to what? It will continue to compare, even if it is what? It is matched a particular character or a particular case. So you need to just add a break statement. Break after each and every what? Each and every case, you are supposed to have a break. Break. Right, the last one, there is no point in having a break because as soon as I evaluate that one, it will just get to the end of what? End of the construct. So it's somehow maybe optional to maybe add a break there. So if I now run this, it now gives me the correct output. So it will start from what? Top, or it will start by comparing with the first case. It compares with A. If there is no match, it tries what? It tries E. Right? If there is a match, it prints what? Vowel. Then it will break. This keyword break, what it simply does is that it will want terminate execution of the switch, and then it will pass control to the next statement after the what? After the switch. So the next statement after the switch are supposed to be found what? After that curly brace. So those are the statements which are given control to what to execute. The moment there's a break, it will terminate execution of that particular construct. Even if it's an if, a while, there's a break, it will actually terminate execution of that particular control structure. And then it will pass control to statements immediately after the what? After the control structure. Right, so we are saying this switch variable, it can be an integer, it can be a string, it can be an enumerated data type. We haven't covered enumerated data types. We'll cover them in future. Right, so what we have here is more or less similar to an if statement where you are using an equality operator, where you have maybe something like if maybe later. If later is equal to what? Is equal to A, like that. This is the kind of maybe a comparison which is being done here. So instead of having a number of if statements, you can maybe just use a case. In that case, it becomes more readable than maybe having if clause. But you should always remember that it will continue to check if there are any matches if you don't add those breaks. Right, I think that's all about conditional statements. Are there any questions before we move on to the looping constructs? Huh? So that default is more or less similar to the else clause, which may be used if you want to capture maybe all the other scenarios. Because here we are saying we want to check if a particular character is vowel. So these are the only vowels. So if you type anything else or initialize later to anything else, that will be catered for by the default clause. It will take care of all the other cases which are not maybe listed here, to take care of all the other cases. Right here, the other option might be to maybe remove these statements. You can remove all these statements since they are just the same. All these statements, you can remove them. And you will still get maybe the correct output, but I don't think that will be the best approach, because it continues to It will continue to check even if there is a match. Because if you have got let me remove these spaces so that you can see the whole construct. What is the problem with this approach? Maybe in terms of efficiency of the program. Huh? If we have something like this, what is the problem? Because here we are saying car letter is equal to what? Letter is equal to E, right? Then we have our switch construct. Then after that we say case A. It checks if letter is equal to A, right? It's not equal to A. Then it tries the next next case. Is letter equal to E? Yes, right? So now that there is a match, it is supposed to break and exit the switch construct. But it's not exiting because there is no break immediately after this case. It will try the next case. Even if it has already found the match here. So it will try the next case until here when it comes across the break, that's when it is going to terminate. So it will continue trying to say, because we simply want to be able to print. So even though it works, but it might maybe affect maybe the efficiency of the program, because it will continue to make the comparisons, right? Even if it has already matched a certain case. I think that's all about the switch. Are there any questions? Let's now move on to the looping constructs. So with the conditional statements, we said that you have got a logical condition which is supposed to evaluate either true or false, right? And when that condition evaluates to true, we are supposed to have a block of statements which is supposed to be executed, and if it evaluates to false, you have a block of statements which is supposed to be what? To be evaluated. Right, so we now want to look at situations where maybe you have got a block of statements which are supposed to be executed a number of times, or you want to continue doing something until a certain condition becomes what? Becomes false, right? You want maybe to continue reading input until maybe you are tired, until a certain condition becomes true. You want to continue adding what? Adding numbers until, or you want to continue reading input from a file until the file becomes empty. So in that case, you cannot use what? You cannot use an if construct, right? We are saying we have got a set of statements which are supposed to be what? To be executed or repeated a number of times, or until a certain condition becomes what? Becomes false. So in that case, you can use loops, right? So if you know the number of times the statements are supposed to be what? To be repeated, then you can use the for loop. If you don't know the number of times, or you want to repeat a certain execution of a certain block of statements until a certain condition becomes false, then you can use a while loop or a do while loop. Right. For example, maybe before I look at an example, this is the syntax of a for loop. Right. We have got the keyword for. Then we have open bracket and close what? Close bracket. Then here we have got three statements or three arguments. The first one is the initialization. Right, then we have got the logical condition. Then we have the logical condition, which is more or less the same as the Boolean condition. Then after that, we have got the counter update. So these are looping constructs. They have what is called a loop control variable, which will be keeping track of the number of times the block of the construct would have been executed. So we are saying here we have a block of statements which we want to execute a known number of times. So it will be counting the number of what? The number of times, right? So that is called the loop control variable, which is supposed to be what? To be updated. For example, maybe we just want to print numbers from maybe 1 up to what? 1 up to 10. We want to print integers from 1 up to 10, right? So we need to initialize our loop control variable. We introduce a loop control variable. We can say int x, that's the loop control variable, is equal to what? 1, that is the starting point. And then what is the Boolean condition? We are checking if x is what? Is less than or equal to 10, because we are saying we want to print the numbers from 1 up to what? 1 up to 10. So that loop is going to be repeated 10 times. It's going to be repeated 10 times. So we then say semicolon x less than or equal to what? To 10, then semicolon. Then we update the what? We update the loop control variable x. We can use this shorthand x plus plus. Right? Then after that, we can simply say system.out .println. Then we simply print maybe the value of what? Of x. So what happens here is that the first time this loop is actually what? Executed, it will start by initializing what? Initializing the loop control variable x to 1, right? Then after that, it will check if this condition is still true. So our x is 1, so it will say is 1 less than or equal to 10. If it is true, then it will skip to this block of what, or it will execute the block of what, block of the 4 when the condition is what is true, right? Then it will print what, the value of x, which is currently 1. Then after it is executed statements which are in the block, it will then go to that part, right? And then it updates what? It updates the loop control variable. It becomes 2. After updating, it will then come to this what? Statement, where to check if the condition is still what? True. Is 2 less than or equal to 10? Yes. Then after that, it will execute the board of what? The board of the 4, where it will simply print the value of what? Value of x, which is currently 2. After executing the board of the 4, it will then update what? X, until that condition becomes what? Becomes false. Until that condition becomes false. So if I just run this, I expect it to print those numbers, as you can see. Right, that's the for what? That's the for loop, which we are saying you use it in cases where you have a block of statements which you want to execute for a certain number of times. Or just want to print a certain what, a certain string, maybe like vowel 10 times. Right, you can just maybe use a what, a loop. It will repeat the same what, block of statements a certain number of what, a certain number of times. Right, then we have got the next looping construct, which is a while loop. Right, with a while loop, you normally use it in cases where you have a block of statements which are supposed to be what, to be repeated, but they are supposed to be repeated until a certain logical condition becomes what, becomes false. They are supposed to be executed until a logical condition becomes false. So you'll be having this syntax is like this. You have while, then we have a logical condition here, right? Then we have a block of statements which are supposed to be executed as long as that condition is what, is true. The moment it becomes false, it will terminate execution of the while. Right. For example, I can say this one, you really need to introduce what? You need to introduce maybe a loop control variable to actually what, count, or you can actually maybe write your program in such a way that maybe there is a prompt, maybe where you prompt the user to input what, to input maybe a response. Do you want to continue? Then if they say yes, then you continue. If you say no, then it will what, it will terminate. So as long as a certain condition is true, it will continue what, continue executing. If you look at that assignment that you are working on, that tutorial question that you are working on, where you are supposed to want to write a program which calculates maybe the area, volume of a what, of a shape, right? You might maybe prompt the user, do you want to continue? If they say yes, then you say enter maybe the dimensions of what, of the shape, right? Then it calculates and displays the what, the area and the what, and the volume. Then they get the prompt again, do you want to continue? If they say yes, so you can actually use a while loop where you want to repeat a certain block of statements until maybe you say no. As long as you continue maybe giving a response of yes, it will continue what, it will continue executing a block of what, a block of statements. Right. For example, here maybe if I want to maybe write that for as a what, as a while loop, right? We want to maybe just do the same, but using what? Using a while loop. We are saying we want to maybe just print maybe vowel, or just print the numbers 1 up to 10. What we can do is we can introduce a loop control, a loop control variable, like int maybe count is equal to what? Is equal to 1. We give it an initial value. Then we say while maybe count is less than or equal to 10. While count is less than or equal to 10, maybe you just want to print system dot out dot print line. What do we want to print here? Maybe we want to print maybe that. Then inside the while loop, we need to update our what? Our loop control variable count. We need to update it. Right, like that. So we initialize it to 1. Then we come here. Then we test if that condition is what? If that condition is true. Right. So we are saying as long as that condition is true, it will continue to execute the body of what? Of the while loop. And it will exit when the condition becomes false. So we say is 1 less than or equal to 10. Yes, it's less than or equal to 10. Then it will print what? Vowel. Then it will update counter so that it becomes 2. Then it will test that condition. Is 2 less than or equal to 10? Yes. Then it will print vowel. Then it updates the counter. It becomes 3. Is 3 less than or equal to 10? Yes. Then it prints until it gets to 10. When it gets to 10, it will check is 10 less than or equal to 10. Yes. Then it will print for the last time. Then it updates the counter to 11. Is 11 less than or equal to 10? No. Then it will exit and then pass control to the statement immediately after that one, that while loop. So that's the while loop, which you use in cases where you have a block of statements which are supposed to be executed as long as the condition is true and you want it to terminate when the condition becomes what? False. Right? Then we have got what is called the do while loop. Unlike the while loop, with the while loop we are saying you test the condition first and then you execute the body of the while loop when this condition is true. You test the condition first and then you execute when the condition is what? Is true. With the do while loop, you start by executing the body and then you check whether the condition is still what? Is still true. So the difference between these two loops is that with the do while, the block is executed at least once, even if the condition is what is false. The body of the do while is executed at least once. Unlike with the while. With the while, for example, if the condition maybe is what is false, like if I initialize count to 11 and then I run, I don't expect it to print anything, because that condition is what? Is false. But if it was a do while loop, it was going to print first. Then after that, it would test if the condition is true. Then it will realize that the condition is what? Is false. Then it will not do the next iteration. So if you want to maybe to write a do while, I can simply copy, cut that. Then I put do there. Then I put the while after. Then I terminate it with a what? With a semicolon. That then becomes our do while. So if I run this, like I said, I expect it to what? To print once, but the condition is what? Is false. So that's the while and the do while loop. Can you maybe have a practical example where you can maybe use a do while, where we might want maybe to start by performing the task and then you check if the condition is what is true. Huh? Where can you use it? Where can we use it? Where you want to execute a block of statements, then after that you want to, we have a block of statements, and that block is supposed to be executed at least once, regardless of the condition. You know that it's supposed to be executed at least once. Huh? You can't think of any example, guys. Huh? Let's proceed. There's another conditional construct which is called the ternary operator. The ternary operator. This is the ternary operator, that part which I have highlighted. Right? It's more or less like or similar to the if-else clause. If you have an if-else clause, you can use the ternary operator to express it like that. Because this is maybe just the same as saying if then our condition, this condition, right? Then we have what? We have result, or let me maybe just write it properly. So we are saying that is just the same as saying if x is less than 10, then res is equal to less, and then else res is equal to greater, right? Then system.out println res. Right, so we are saying this is just the same as what? It's just the same as that those two statements. That's the ternary operator, where we have a conditional statement here. So this question mark is more or less like we are asking, is x less than or equal to 10, or we are trying to evaluate that conditional expression. Is x less than or equal to what? To 10, right? If this evaluates to true, if it evaluates to true, res is then assigned this value, which is before the full colon. Otherwise, res is assigned what? That value which is after the colon. So this is the value when this evaluates to true, and the value when it evaluates to what? To false. So we are saying string res is equal to, then we have our logical expression, and we are saying when that expression evaluates to true, res will be assigned what? It will be assigned less. If it evaluates to false, res will be assigned what? Greater. And we are saying just the same as what? As that. right? So that's the output that you get. That's the ternary what? That's the ternary operator. You can actually write an if-else clause using what? This approach. You can use it. Right, I think we are now left with one construct, which is the advanced for. The advanced for. It is normally used with the collections or arrays or sets of values which you want to treat as maybe one collection of values. You want to maybe process all the values in a collection or in a set or in an array. I think we have to look at the advanced for each after covering the arrays. Right? Are there any questions? If what? We are not demonstrating if, then do the else if. If, else. Right, then maybe the other thing, you can actually embed any of these constructs inside other constructs. I can say if, then a condition, then I can have maybe a while loop or a for loop, or I can have a while loop inside another while loop, or a for loop inside a while, or a while inside a for, or you can actually embed depending with what you want to do. Or you can have maybe an if side inside another if. You might say maybe I have a condition like maybe sex and then maybe you've got age. You might say if maybe sex is male. You might maybe say if sex, I have not defined these variables. But you can say if maybe sex is what is male, right? Then inside that you have another condition. And then you say if maybe our age is what? Maybe greater than or equal to 18. Right? Then you have a block. Right? Then you can have the else what? Else clause. Where you are now saying else maybe if sex is equal to a female. Right? Then you have what? Then you have another block. Right? Then you have if. So here, where I have specified that block, I can also have what? An else. Then another what? Another block. So you can actually embed an if inside what? Inside another if. Or embed a for inside another for, depending with what you want to what you want to do. Like that. I have not declared these variables. But we are saying you can actually embed. So this is the outer if. Then if that condition is true, we have another what? Another inner if with an else what? Right. So if sex is not equal to male, then maybe this part is what is executed. And you might also have another what? Another block there. Right. Then here you can also have other conditions. You can embed another condition here. Maybe if what? Age is greater than 18, then if what? Maybe if employed maybe if employed is equal to maybe yes, then you have a block. So you can actually embed an if inside another if, a while inside an if, a for inside another for, and so on, depending with what you want to do. I think it's almost time up. I think we can stop here.